We are going to discuss about the demultiplexers, or we can call it as data distributors. So these demultiplexers perform the reverse operation of the multiplexers we have learned in the previous video. So the demultiplexer takes a single input and distributes it over several outputs. So we can call it as it is an 1:n device. There is only a single data input will be there, and number of available outputs lines will be there. Okay. So here we can also treat it as a rotating switch, because the input is always connected to the rotating switch, and based on the select inputs we can direct this input to any one of the output lines. And also, same as the multiplexer, we know that in the case of multiplexer, if there are n select inputs, 2 raised to n input lines will be there. So here, if there are n select inputs, then 2 raised to n output lines will be there. That is, we can direct the input to 2 raised to n output lines. So this is a normal demultiplexer. And just an example of a demultiplexer, there is a 1 line to 4 line demultiplexer. So only one input will be there, that is we are treating it as D. D is our input, and 4 output lines will be there. So we need to select input for directing this input to 4 output lines. Okay, and how it is possible here? Suppose our select inputs are 0 and 0. Select inputs are 0 and 0. Then at that time, what will happen to the first AND gate? From the figure, we understand that the data input D is given to all these NAND gates, all these 4 NAND gates, and S1 and S0 are also given to all these 4 NAND gates, either in complemented or uncomplemented form. Okay, so when S1 and S0 is 0, 0, so here it is 0 and 0, S1 and S0 are 0, 0. So for the first AND gate, the inputs are D, and the second input will be 1, because here you can see a NOT gate. When we are giving S1 as 0 here, the output of the NOT gate will be 1. So the second input will be 1, and also the third input will be 1. So the output of this AND gate will be D. Okay, and for all other AND gates, the output will be 0. So we can take an example of the second AND gate. For second AND gate, the first input is D, and the second input will be 1, and the third input will be 0, because S1 and S0 is 0. Second input will be 1, because we are using a NOT gate here, and the third input we are directly giving this S0 as the third input. So the output of this AND gate will be 0. And also we can check for all these 4 cases: 0, 0, 0, 1, 1, 0 and 1, 1. Okay, and for the first case, the output D will be obtained at the O0 output and O0 output, and for the second case, the output will be obtained at O1, and for 1, 0, the output that is the data input D is directed to O2, and for 1, 1, the D is directed to O3. Okay, and one more example is a 1 line to 8 line demultiplexer. So only a single input is there, D, and there are 8 output lines will be there. Okay, and we need 3 select inputs for directing this only a single input D to 8 output lines. We need 3 select input: S2, S1, S2, S1 and S0. Okay, and we know that the combinations will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1 up to 1, 1, 1. Okay, 8 combinations will be there. And we can observe the first case, that is S2, S1, S0 are 0, 0, 0. Okay, for the first case, what will happen here? This S2, S1 and S0 are 0, 0, 0, and we know that this D is given as input to all these 8 AND gates, and for the last AND gate, that is for the 0th AND gate, that the output will be O0. Here the output will be O0. And for the first case 0 0 0, what will happen, that is S0 is 0, so we are using a not gate here, so the output will be 1, and it is directly given as the input to the last that is 0th AND gate. And S1 is also 0, so through a NOT gate we are giving as the input to the last AND gate, and S2 is also 0, so through a NOT gate we are giving it as the input to the, it will be D, then 1 1 1. Okay, and so the output will be D, O0 will be D. So this is the first condition. Okay, so likewise we can check for all other conditions, and this data inputs D will be shifted to O1 O2 O3 O4 based on these select inputs we are giving. Okay, so this is a demultiplexer. I hope all of you understand well. So by this we are completing our third module, that is the third module of digital electronics and logic design subject. And thank you.